everyone!
I'm Shazolina.
I'm Logambika.
And I'm Kairin.
Hi, my name is Afwan.
And I am Amsha.
And we are from
MRSM Parit.
Based on previous research, most of the researchers have been studying on how to modify the cookhood system just looking at their mechanical features. Unfortunately, there's a limit on research about the additional filter implementation. So most of the DIY enthusiasts have been using a non-woven fiberglass fabric as their additional filter. Unfortunately, the usage of this fiberglass fabric was not sustainable since it cannot be decomposed and also it can give a direct exposure of harmful pollutants toward our food, which make the food become improbable to be eaten. Next, what we're going to do in this project is that we will be using a natural fiber as an additional filter and seeing its potential of being additional filter on the cookhood.
The natural fiber that was used in this project is Luffa fiber, which was purchased through online shop. The Luffa is in unbleached and dried form. All of the samples were cut, trimmed into rectangular shape by using scissors, cutter and cutting mat. Then it was boiled in hot water for 30 minutes to remove impurities. After that, the Luffa fiber were left to dry on a tabletop at room temperature. Then the Luffa fiber was compressed using steam iron. Then it will look like this.
You must be asking why we use Luffa fiber. And the reason is we use Luffa is abundantly exists in Asia, and it is also easy to find, and it is also recyclable because it can be treated by using stearic acid.
In this project, Luffa fibers were treated with stearic acid by using the immersion method. First of all, 70% of ethanol was prepared through the dilution of the 95% of ethanol. Then 2% concentration of stearic acid in ethanol solution was prepared by dissolving 60 grams of stearic acid in 3000 ml of 70% ethanol at 80 degrees for approximately 10 minutes until it dissolved completely. Next, the Luffa fibers were immersed for 6 hours in the stearic acid solution. After that, the Luffa fibers were removed and left to dry on tabletop at room temperature.
So basically, why was the treatment of stearic acid is important? It is important so that it can fractionalize the characteristic of Luffa fiber from hydrophilic to hydrophobic. With this, the rate of oil absorption will also increase. Not just that, the rate of oleophilicity of the Luffa fiber also increase.
The performance of Luffa fiber as additional cooker hood filter was tested by attaching it to the surface of cooker hood by using magnetic tape. Since the surface of cooker hood is made of metal, it is easier to use magnetic tape to attach and detach the additional fibers. The assessment of oil absorption capabilities was conducted by using oil control films. The determination of oil absorption capabilities was assessed by observing the oil bloating area on the oil control films.
TDS meter is used to determine the amount of dissolved particle in the water by using parts per million or ppm. The used and unused fabricated Luffa fiber was soaked in distilled water to test the amount of dissolved particle in this soaked water. The data represent estimated amount of pollutant absorbed by Luffa. 14-in-1 reagent strips is usually used to test the quality of water in terms of total alkalinity, pH, hardness and the presence of certain substance. To utilize these strips, the used and unused fabricated Luffa fiber was soaked in distilled water to test for the presence of any of those substances in the soaked water. This can help to identify the type of pollutant absorbed by the Luffa fiber.
The table shows the oil or grease content is higher without an additional filter. After the treated filter was removed, the oil content on the original filter decreased, indicating that the treated filter is absorbed more oil, leaving less for the original filter to filter. The untreated filter absorbs less oil, requiring the original filter to filter out more oil.
Well, that's all from us, student from MRSM Parit, Malaysia. Bye.